All right, number 8. I hope you don't mind that I'm going to use the same paper I just used for number 7. So we'll do number 8 down here. All right, so the question says, form a polynomial whose zeros and degree are given. Well, this one, it gives us a list of the zeros with this thing called multiplicity. We know from solving quadratic equations that sometimes you get the same factor more than once, so it'll produce the same answer twice. With polynomials, you can have the same thing. You can have a factor that repeats itself a couple of times, and each one of those same factors will create the same zero. All right, so we have a 0 of 5 with a multiplicity. That basically tells you how many times the factor shows up for that 0. That one has a multiplicity of 1. So that means my polynomial will include a factor that produces the 0, positive 5, right, x minus 5, once. I'm just going to stick a little 1 on there. You don't have to when you put it in the polynomial, but just to keep track of it. Again, just to talk about it as we're going along, x-intercepts, if I was interested in graphing this, which at some point we will, the graph of the polynomial we are about to create would pass through 5, 0. All right, then it gives us another 0. It tells us another 0 of this polynomial will be 2, and it will have a multiplicity of 2, which means that the factor x minus 2 to produce a 0 of positive 2 will happen twice. In other words, it'll be squared. X minus 2 times x minus 2. And the x-intercept 2, 0 will appear on the graph. It can't appear on the graph twice. You can't graph the same point twice and know it. I mean, you could graph it twice, but it would be the same dot on top of the same, so this one would only have 2 x-intercepts. Now, we got the zeros that were listed, and it wants a degree 3. So this 1 plus 2, that's the degree. The degree will be 3. After I multiply this out, we will get an x cubed. So P of x equals